your device out, and we can just like do first step, register your account. Like there's a cloud service, pretty good. So you can directly register from cloud.dify.ai. All right, just that's the address. Just need your Google account or the other account, like GitHub account, and that's it. I'll also open up a new account, so to demonstrate. So that's almost how it looks like brand from a brand setup. Okay, maybe let's warm up a bit for from where we are first, shall we? Okay. Since there are new faces again today, welcome Jay and Hers.
Thank you so much.
Yes.
Hello,
And
guys.
some Ethan also, yeah, come over. We are the that's our association, Macau Data Science Application Association. So we regularly do meetup and data labs, aim for sharing knowledge about machine learning, data science, and now it's more on AI and LLM, RAG. So thanks Patrick for providing us the venue, and very nice. And Wi-Fi, since if you haven't got a Wi-Fi, there's a Huawei Wi-Fi set up here. Okay, from Chuang.
Oh, no, from CTM.
Okay. The tech supporter day. Right. So today our session will cover first Dify. Dify is a tool, like a local platform. Platform is like it provides just backend as a service for development of the LLM, so-called the LLM app. So we all know developing of app, but adding up LLM, what's the difficulty, and why do we need a local approach? Aside of from last session, Victor here already guided us the LangChain basic, right? With just coding base, we already can be able to achieve some app based on the LLM development. So Dify, on top of this, will add up the local experience. So it's more intuitive for those who maybe not so good as coding, but who like to be able to see, be able to make a tuning of the tool itself. And second session will be Vanna AI. So Vanna, also on top of Victor's last session, Victor already showed us like a LangChain, how to do text to SQL conversion. But Vanna is another framework that can be able to do this in a more fancy way. And the third section will be also from Victor today. He will go through some basic core technique to build up an RAG from scratch with NumPy and NetworkX. All right, that's our session. So first part, that's a very basic question we were always thinking of. So prompting versus fine tuning versus RAG. That's a basic question, right? What's the difference, and when do we use it? So I guess a couple of you already or have such basic knowledge, maybe. But when to use is the key, right? So, and can we use all of them in one agent? And second question is, when we need to automate this, And if we want to put multiple agents to do one thing together, how do I orchestrate the whole thing? So that's where it comes Dify. Okay, so Dify is the out-of-box usage. Like as just now I told, everyone can register the cloud service by their own, and so it has basic 200 free calls for OpenAI. It's so-called the sandbox plan, but it can also top up, of course. So and then it's easier and intuitive for the usage. It solves some of the problem here, but I just demonstrated through this for you guys to get understand quickly. Okay, so firstly, when you come to this page, you'll see it's a whole blank page. On the right-hand side, on the top, there's a setting here. The setting here, and oh, sorry. First thing first, I should tune it to my language to English. So setting English, since there's a whole new account. Okay, so inside the, I think the setting, instantly you can see this list of the models. You can set integration with the application itself. So first you can see OpenAI, of course. Anthropic is the cloud, right? Cloud LLM, and sort of Microsoft, Google Gemini, NVIDIA, Cohere, all these list of LLM is all possible to integrate with. So you can try to search and find one you're familiar with.
Does Macau able to select the ChatGPT? Do you need to VPN?
VPN if you need. No, you don't.
You don't. Okay.
That's a beautiful part.
Yeah.
But that's a 200 message credit for free usage. But on top, if you want to use more, you just need to key in your API key.
Okay.
The beautiful part is that the platform itself, since it's a cloud platform, right?
Yeah.
Is somewhere already being able to connect to OpenAI. Okay. So another important Olama is here, right? It means you can set up local deployment. So you can put as many elements as you want behind Olama, right? But firstly, you can just connect to Olama, and then Olama can does everything for you. So that's the second part, how we deploy it to local. Replicate also very famous now, but of course some of them you can see there are some Chinese LLM. Maybe not all of you have seen before, but what it tells importantly here is it can almost compatible with either side, like Chinese and American, all possible, right? So comparing with some other platforms, right? Maybe it only fits only one side, but this you can see it's almost possible. So that's very the beautiful part of it. For first thing first, okay, and then yeah, can just generally browse it. And second thing is API. Okay, so it enable you to develop your own API, and so you can connect your app like with other API you've developed somewhere else. So by just API talks, right? So this is its extension is very useful here. Okay, so nothing else. And on top of it, it shows almost 4 sections. Let's just see the first section, explore. You can see there are many templates that are being developed by someone else, like YouTube channel data analysis, travel consultant, all these kind of basic ideas. They've already put it in there. But also notable, on the corner, it shows there are different things. For example, this is presenting a workflow, and this is a chatbot with, and some else is like an agent logo, whatever. But basically, the fundamental they are same. Okay, now this one stands for agent. Okay, so you can play with them anything instantly, quickly. For example, I'll take one. Which one should I choose?
So these are all pre-built apps that allow people to use the template immediately.
Yes,
Okay.
pre-building. Yes.
That's cool.
So I just choose one, like travel consultant, right? So you can see its interface now. So we now move to the studio side, okay, the second page. So it open up this interface. This is the more, this is the main interface we'll be focusing on, because that's where we developed the stuff. So under orchestrate, you can see instructions. Okay, instruction, of course, we all know this is a prompt engineering. So you put your prompt here. So you are what kind of role? A travel consultant, right? And the skill set you should be, you should acquire is like enterprise in using tools, provide comprehensive information. Blah, blah, I won't read through all these. And the goal is to provide user to a rich and enjoyable travel experience. That's the prompt, basic idea. And variables, like for user to input the destination, number of days they would like to for the travel, and how much they would like to spend. Context here we'll on hold for now. And the tools, you can see it's integrate with the Wikipedia's API. So at some point it will loop to Wikipedia and then find some information. Okay. Also a web scraper. This part will scrape some information from not sure which web. Okay. So this is a template someone made already. So on the right side you can see for first that by default you should be able to getting the same page as me, right? So on the top you said GPT-4 1106 preview, right? Oh, it says deprecate for some reason. Okay, but I think it's usable right now. And then the page here is just how it looks like an app. So it provides the first thing, the question is like, what's your destination? How many days you would like to travel? What's your budget? And that's the answer. Okay, that's the answer actually. And some feedback or next question output from the last question. Okay, so let's get a try of this. Now actually I can click this and to open up another individual page, right? So I would like to travel to France, okay, for 5 days. How much I have? Okay, so it's a drop-down box. So like I can spend 10K. Okay. Oh, so this is an opener. So it provides some fixed context to talk to the user. Okay. So I can select one of these questions. So for example here, this one. Okay, so this indeed deprecate. I'm sorry, this one need to change. So to change this one, we just click here, and then under the model there's a list of the LLM. Okay, so of course there's some other choices here like 4.0 mini. Okay, I'll pick 4.0 mini. So parameters also available like temperature, top P, you can tune them here. But I'll just leave it as default, and then I'll just publish again. Remember, always publish it before you test run it. So it takes the parameter. So I'll try again. Okay, so now you see the first step is it's already now it's generating. Okay, since I asked 5 days, so it generates 5 days for me. Okay, and then final answer, and then provide the next question. So in the beginning, there's
tools icon here says use Wikipedia search, right? So you see the requests I input before, like Paris and English. This is actually analyzed from my input, because since I only select one of the question here by default, right? So it gives me the response, but somehow in a JSON format. That's not human readable. I mean not common user readable, but it's already very nice to read. So, and of course, LLM has its own ability to give this answer into Markdown format. So it makes the content more easy to read. Okay, so that's how it works. So this is a base idea. I randomly just pick up from the template, and it already does this this work for me. Like it's acting as a professional travel consultant. It provides the suggestion of this. I guess there's nothing new, right? It's just like an average Copilot or ChatGPT. But important thing is the context tools. We haven't started yet, right? We can add up this stuff here and do our own work. So for this template, I wouldn't touch it anymore. I'll change it to something else. Okay, so I'll just create from blank. Okay, so create from blank. We can see there's three or four types of formats here. So chatbot, like I said, chatbot, text generator, agent, but these are almost very similar. So you can have fun to play with. So I'll just pick up maybe maybe just agent for now. Okay. Since the reason I say so, because the chatbot, under the chatbot is a basic method, but there's also chat flow, which provides very similar experiences, the workflow. So there's not much different right now. So I'll just pick an agent. Okay, so this provides me a blank page from the beginning, so I can do whatever I want now. So I could use my previous sample here. So I just say fix prompting and always begin replying my name. So under there, I add up a variable, say the name, so instantly pop up the same thing like on the right. I have to input my name, and it would automatically know this dynamic value and reply me. So a simple demo, it will be from the big scratch. I run the app. Where's not response? Something's wrong. Oh, I have to start talking, of course. So it gave me the template like I want. Say greeting LM, blah blah blah, thank you. It gave me some attitude like this, and right. So that's the basic bot setting. So under there are some other tools. So you can to simulate the travel consultant, it can provide a conversation opener. So I can add up the conversation opener here, like always seeing a message on top as the beginning, right? Without waiting. Okay, so this a good day. Okay, I put here, and I could also choose like a follow-up conversation, or I can do text-to-speech. I can get it to read it out, and some voices also choosable from here, like a female, male's voice. I pick up a random one. and show me the citation if I do the RAG part, like the context part, but for now it won't provide me much, I think. And content moderation was for if there's something sensitive I wouldn't want to disclose, I can set it here. Like I can set up some keyword and let's talk about something else, shall we? We don't want to talk about the politics, for example. So we can do a test for this one. Okay. So after that, you instantly ask me to restart, and I'll just update it and restart here. Okay, so this is not a new one, so I have to delete the previous conversation, and then you now provide me the new one. So now it provides me an open conversation, okay, as I wanted. Otherwise, I'll be waiting like I don't know what's going on, right? So this is a first step.
Thank you for sharing and for the efforts you've made during our conversation.
Okay, nothing meaningless. So it's just reading out the context there, right? So it provides the general app experience, right? So when you talk to somebody, and you can hear that the speech is very natural, like a real human, right? So this sample you can try is a feature you can enable them there, the basic features, okay? Right. So these very basic ideas about, we all know. I mean, the experience from the Copilot, ChatGPT is nothing new. So I just close it. So for Dify, it supports, like I showed already, mainstream LLMs is a list bunch of the LLMs. So it provides the intuitive prompt orchestration interface that you can add up, you can do tool, you can pick your own tools, and it does a high quality RAG and a flexible AI agent with framework, and in a local format, easy to use. Okay, so I'll just demonstrate the RAG part for everyone. Let me see. So to start with RAG, we already have to build a knowledge base. So that's the third session here. Okay, so knowledge base, it also supports the mainstream formats like text, markdown, PDF, etc., PPT, like drag and drop experience. Very convenient. Do I have one here? Like now I want to build a system for doing an exam review with me. So I'm taking an exam for SRE. SRE stands for Site Reliable Engineering. So I'll just pull up a PDF. The PDF itself is some Q&A questions, right? So I wanted to do some exam review with me. So I'll just drag this into I'm sorry, this one. So oops, did I? Okay. I'll just drag this into the box here. Okay. So for the next, it has different way to process this knowledge for me, right? So chunk setting, like you can do automatic. Usually I just leave it automatic way. And index mode, high quality, I leave it as a default. Embedding model, it uses a list of embedding you can choose from GPT site, right? So text embedding, there's a list of three kind of different embedding. I'm not sure exactly the detail inside there, but as you can see, it provides as many choice. Okay. Now, this is the important part. You can ask it to do either vector search or the semantic search, or a recommended method would be hybrid search. Okay, so hybrid search it does the benefit from both methods, and after that it would do an extra step for re-ranking. So I'll just choose the hybrid search. And but to do the hybrid search, I have to pick up my re-ranking model from here. Okay, so since I haven't set one and it says deprecated, I just have to go back to here. Let me see. Does OpenAI provide any embedding or re-ranking? I'm asking. So it does not. Therefore, I have to find out one for re-ranking. The most common one here would be, I think it's Cohere. So it asked me for API keys, but lucky enough, Cohere does provide some free keys, I think. Cohere. So where's the key? That's the main action I do every day, to search for a free key. For re-rank one. Let me see. I forgot last time where I found it. They changed the web. Maybe it does not need to register, right? Or either, let me try another one. It's not either Cohere or another one is called Jira, I think it's Gina AI. Okay, so here's API. I guess that's the one. API key. Yeah, this is the one. I don't want to read it. I know it is, so I just pick it. Okay, and I go back and I find Gina here, set up. Okay, great. Okay, now I have Gina set up in my list. So if I go back to the settings, okay, should be able to find Gina sitting there, right? So I want to find out if it does have re-ranker. Yeah, re-ranker, lots of re-ranker. So it should be good enough for me to use. But also notable, you can turn on and off them if you don't want this many lists to be showing up, right? Okay, so that's the general one. By default, you can give, you can assign a model to different usage. So as you see, since I set up Gina here, it instantly read it and chose one for me, right? So it's pretty good enough. And others I leave us from OpenAI. Okay. Now if we go back to my sample, oh, it's right there. Okay. So it automatically fit this for me without any waiting. Okay, then it's good enough. I can do save and process. But on the right side, you already see the preview. It's already chunked by a number of tokens. It does this job for me. It said knowledge created. Okay, very good. Embedding maybe asked me to upgrade because only if it needs more, if the length is more. Okay. So after this, I get this documentation sitting under my knowledge base, right? So this one is under 10K words, and the file isn't big enough. The limitation should be like 15 megabytes something, for the free account. So, but obviously you can upgrade and do more. It's possible, I'd say. So it's right there, and very good for me to do my work. I need to do an exam review now. Okay, so I just pulled this up since I already said it before. So, oh, did I use? I forgot to change this. This is Chinese still. Okay, so this is my workflow. The other importance is the workflow experience, right? So this Chinese says starting, okay? Simply enough, it just give different inputs here. Okay, so each node, you can do some process by itself. Like you can think of like each node can be one agent, right? Like here, I put an agent to iterate with O1 mini, right? And for this node, I put another agent to interact with GLM. Okay, so another one here, like do the search. So I have 3 agents here, as you can see. So each agent can do different work for me, but together in a group. So that's multi-agent orchestrate, right? But with the visual, you can instantly see at each node it flow to how it processes the way, the path. So that's the beautiful part of a workflow experience. So the knowledge I created, I can set it here, right? So I can do a retrieval setting. I can choose my knowledge, and then I can choose is a hybrid mode, as you can see. It's a hybrid mode, right? Hybrid search mode. So after the start, I will do adding one node, like knowledge retrieval, and then set this just like here. So if you're following, I mean, doing the practice, you can try this, okay? And then a third node, I will do a so-called the relevant determination. So since I have so many words and inside this my knowledge PDF, but the user, just me, I mean, sometimes can ask some questions that not be able to be found from this document, but I would like to do some search from internet, right? So this nodes here would help me to find whether my question is related to the knowledge, or else I should do a search through the internet. Okay, so the prompt I given here is based on the context and the user question, determine whether the context is relevant to the question. If it is, it give this value, related has found, or otherwise give related unknown. Okay, and then output the answer directly. Okay, but you have to read through the context first. Also, you have to understand users' questions. Okay, so how I input these parameters here is that I just do a slash, and it automatically lists out the possible value for me. Okay, so this is how I do the context here, right? So I do slash, and I can see context to add, right? Simple enough, right? Then what else? The user query here, okay. So, and then I put the if else here. So it helped me to determine whether it has found value, the output from the previous node, right? And for here, I give 2 ways. One is to answer my question from the document. The second path is to do a search through Wikipedia and then find me more, because my document wouldn't have contained this. Okay, so I'll just run it to show how the performance is like. Okay, again I have to start a new conversation. Okay, so this is my assistant doing my SRE exam review. Okay, so tell me about CNCF. So it's generating, but the performance, did I choose O1 mini or something? Well, it's stuck in. Oh, okay, here we go. Oh no, it's not the way I want. What has gone wrong? Okay, maybe I'll tell you why I find it's not good. Okay, so workflow process, it showed me the path it actually went through, right? So like I said, the path, I was expecting the, what did I spell it wrong? CNCF is the correct word, right? Cloud Native Computing Foundation is the knowledge I want to retrieve from my documents, okay? So I expecting the knowledge retrieval would give me this answer to match up from the document, right? And then the relevance determination should tell me the information has found, so you go through, answer it directly without going through Wikipedia. But now it does this, so I have to find out why. So tell me about CNCF. I go back to here, and then I just do a preview. So you can see when I run it here, you can find how it does process the whole stuff, right, instantly. Wait, but this one, it does correct now.
Yeah.
It's weird, right? Okay, so that's something notable. At least it's not so stable. So something I need to tune it. But I can't give the answer right now, sorry. It's time consuming. So there's still something, at least this is the correct expectation I want, okay? So during the debug flow, you can see, right? There's no Wikipedia now, okay? Also, you can tell from here, like it visualized for you, right? It went through this path to here. Also, citations, it gave me the documentation I input earlier, right? So it does prove the knowledge was retrieved from there. I can see it, yeah. And the beautiful part here also, for debug purpose, you can explore each step, the input and output. So at each node, right, you have a input, you have the output, so you can check through at which point it went wrong, right? So for the relevant determination node, it output said related has found. Okay, that's the point where it makes the whole process went through the way I want, right? So after the if and else, it just handled the related has found, and then it just asked the next step to go through the QA again, and then just output the answer directly. Okay. So this is a different. I don't know why, but okay. But it already showed. Since it already showed me the second path. Okay, so it proves either way it works, right? So what is AI ops? Maybe throw it a second question and try again. So there's some usage token here while generating, of course. Okay, so this is wrong again. Not so good. Not the way I want. Okay. It means that if I look at the relevant part, it will give me if else. Okay, this is the operation side. I can show you later. I'll just keep something now. Tell me about AI ops. Now it's correct. Okay, that's weird. But it does happen. Sometimes just have to make change to the way. So since here I use a if-else condition. Also before if-else I use the relevance determination and the knowledge retrieval. So I guess the most part, the most critical part is here. That since I use 01 mini, so maybe I change it to some other model. It could provide a better result. Okay, so
Let's try.
Let's try for maybe. Okay. Oh wait, it does provide me the right answer. Okay. Okay. Now it's okay. So what I want to show is, yeah, at each step you can find the input and output. So it enables you to instantly find what has gone wrong and make a tune of the each note. Yeah, and the answer. Yeah. So we know it's a local workflow, so easy to use, and some basic idea about RAG here. So that's a source like 1 year ago from Amazon, and since we know the first part we just demo is like an ordinary agent, a bot to answer straight away, like a zero-shot LLM. So that's the path we already know, right? So from prompt the query into the LLM, and then I give the answer back. That's ordinary zero-shot, right? So after that, what's RAG special? RAG does the retrieval part, right? So like I showed just now, I can have my own knowledge source with the PDF source, right? And I stored my source into a vectorized DB, and then or it does two-way actually, vector index or keyword index. The one I use is hybrid search, right? So it does the two-way, and then it's all in chunks. And then when I do the search, it will find the relevant information and then retrieve it back, and then enhance, or let's say augment my query. Okay, enhance context, right? So this it add up the whole route add up this part, and then so it when generation it not only does the zero shot, but adding the knowledge part. Okay, that's the basic idea of RAG. Anyway, so it solves so different problems. The hybrid search was special, so vector search plus the big keyword search to match up with DB, and then it find both way. It find the relevant chunks, and then after that it will re-rank. The re-rank is will go through the result from both, right? So it gives the score and find the top K. So top K, if you list out like 3 or 5, you can have 5 answers for the next node. Okay, that's hybrid search. Also, there's some other, think of the workflow itself, right? So it's a workflow, so you can orchestrate your own app in many different ways. So you can put agent, 3 different nodes, or you can do agent, like in parallel, maybe, right? So to retrieve data sets together in one time, and then re-rank them together. So that's another beautiful part of the workflow. So you can, when you do thinking of the orchestration, it does either way, right? So back to the original question, what difference between prompting, fine-tuning, and RAG? Okay, so here, so the x-axis is the model adoption difficulty. The y-axis is the external knowledge that doesn't exist in the internet, maybe, because since if you're using the zero-shot LLM, it only does search from the internet. There's some information you store in local, the internet wouldn't be able to touch, right? So the knowledge, external knowledge would be the internal data in that way, right? So start from beginning, a zero-shot or with a few-shot prompt engineering at the left down button here, right? So you just need to add some basic COT, the chain of thought, to ensure it does the basic few-shot result. That's easy enough, provides good result. But when you have, one of the problems is that when you have a long prompting, you need to input there. Even it does this, it costs a lot of tokens, right? So LLM does token token consumptions. So one way is to cut it to chunks. So RAG here, by here, it doesn't help, right? So saving the cost. So dynamically, we can controlize the information. So less token for LLM and saving the cost. So the index, like just now I show you, the index, there are two ways to index them, vector initialize and for the text initialize, the advanced RAG. Right. Fine-tuning is it's actually resource intensive, but once you have a better model, it provides a long-term performance gain. So that's another benefit of this. So to do a best app, maybe like I demonstrate, it's not perfect, right? So it may be utilize all these three kind of methodology together. So I can have multiple agents to work through one process together. So that's the right top corner. So you can have all of them together, working together. So some other RAG painful parts here, including one we just show now is hybrid search, right? So when retrieval, it does a vector DB retrieval, we can do re-ranking, right? Re-ranking after the hybrid search, so it can already resolve this challenge. So some other challenges like for retrieval, RAG retrieval, so task-based retrieval, we can have multiple documents. If the retrieval data are not in the context, we could do query document. If the data is outdated, what do? I can do document versioning, right? So all these kind of different way for solving the retrieval part. And generation is more on operation side. So it's like a response time, how you solve it, some semantic catching. For data security, there's also some other way, but we're more focusing on the left side because retrieval it impacts to the result immediately. Okay, so for Dify, I think that's the demonstration part for now. You guys play with the tool and have any questions or just?
I have. Can we go to the user interface?
Yeah.
Page?
User interface.
The second tab.
This one?
No.
Dify.
Dify. Yeah. Okay.
When you did the demo, is it the interface you used just now?
This one.
My question is, if I have a web app, can I make a connection to this?
Good point. Yeah, possible. So sorry, I forgot to introduce this left side, right? So this is API access. So once you made up the app, the API is ready there. So you just have to embed it to. Actually, you just have to think of, since this is a cloud run, right? But also possible, you can wrap up your app with this API. So it provides the API, but I'm not an expert of API at the moment, but yeah, it's possible. I can answer that, yes.
Okay.
Maybe Vita can help. And yeah, orchestration API and the logs. Okay, logs. You can see the question I asked through, right? Conversation. That's why sometimes I just have to restart a new conversation because all the flow they attach to one conversation ID. Okay, so each conversation ID it can have message. Like I asked 4 queries here, so you can keep log all my queries inside the. Or I can even replay it, right? So it replace my message. Yeah, some other question I asked before. So anyway, So this is a page where you can see and find out more, like a debug of your LLM maybe. And the last one is the monitoring. So you can manage your usage, like how many tokens you consumed and average session interacts. Yeah. So once you publish your app, you can check from there and see how it runs and monitor more. Yeah. Maybe you wonder how you feedback your result and prove it later on. And I think that's possible since it's a workflow. So at some point you can do that. Okay. Any other questions? Yeah.
So I wonder for this Dify thing or for any of the like RAG thing, is it possible for us to import like non-textual data?
Non-textual.
Non-textual data.
Non-textual.
Like if I
Images, video.
so somehow if I could input any images and video in it, and it would just transfer like those images and video automatically to text, then it would be like something even more useful, right?
So I just have to come here, right? So
Yeah.
the knowledge part you're asking. Obviously, this is a context under this import method, but it read through. Oh, but here you're asking since image inside the PDF is it
Yeah, something like that.
it need an extra step, I can say.
step, right?
Yeah, not even image. I mean, even the table you need an extra step.
Okay.
Yeah.
Is it possible to make it happen here? Like, I think the extra step is like we have some sort of converter to convert the image to a textual information first.
Indeed,
and then
indeed.
put it there. So do you
Indeed.
think we can make it happen on Dify?
I'm not sure the roadmap of the product itself, but there's already many of these questions raised. So since people have to use their own knowledge to make up a customized note, I guess it will. It will. Since the knowledge part is at the moment is not perfect. Yeah, the question is very valid. Yes,
Open source project.
it is.
Okay.
It is. Good question. Yeah.
可以啊，
Any more?
本地好處啊。
You want to see the local hosting, right? I will show you.
Oh, yeah,
later.
yeah.
I will show you later. Yeah.
Yeah, I'm talking about that.
Anyone? Anyone more? Okay, I'll move on then. So, okay, so I'll do the second part first. Vanna AI, so SQL Copilot. Okay, so the Vanna in the middle, it does what it does. Well, this is a side Dify. Anyway, this is another AI framework. It just do text to SQL. So it will simply enough. It can interact with database. It has on vector storage. It can interact with any LLM. While it claims for any, I think is majorly just US side, and then it provides a front end as well. So maybe just I open up a collab here. What's wrong with my collab?
你都唔出嚟得埋
可以嘅，我哋會可以。
所以唔使用。
我係幾有其他狀況未到時，我哋有輸送時間。
Sorry, I have to find the page of my own.
Facebook 嗰啲可以 follow 下，睇下咩事。
有 Facebook 我哋認識地方。
佢要俾啲咩表情？Please。
Spell to camera.
Cool 啦。
So to do my Vanna, I just have to find the data set first. I'll use this NBA Shots data set from Kaggle. I'll just find any, like, I mean, there's a 2000. Okay, so this is the data set they provide from Kaggle. I'll just download this one.
NBA shots.
Okay. Yep, I think it's almost set. So I just pulled the data in there to ready my session. Okay, so this is my Vanna Vanna test.
Is your account paid? Google
Colab?
Colab.
Have you paid for the
No. It's a free, yeah, free lab site, yeah, as well. Just like Dify, yeah. Okay. So to start with the my test run, I just pip install Vanna. Actually, it's the Chroma DB is a vector DB inside Vanna, and then OpenAI framework. Also the pandas. Okay. So installation should be fair enough. Okay. And I just import pandas and SQLite 3. Okay, so the differences between the Chroma DB and the SQLite here
Chroma
is,
has error.
huh? Chroma has error?
Error. Depending before it doesn't correctly take.
Does it have error? Somewhere. All the above.
You can try the one you think though.
Yeah, I think I'll just ignore for now anyway. So the difference between is the SQLite 3 is the one I'm going to use to store the CSV data, the actual database. The Chroma DB is the vector database. So it will store for the data generated from the intermediate. Okay. And then I just define a function called import CSV to SQLite using, I name it as an NBA shots DB, okay? And then I just does this run. Oh, what's run? NBA, I download the run one. Why is 2004? Okay. So just put it again, drop this. Is it free? It's free, but it's limited space. Let's try again. Yeah, so I'll just set up my database. So before I can use Vanna to query the database. Okay. So the data, I think you can input as many you want. The demonstration would be just focusing on how the query understand your question. Okay, good enough. Okay, so it instantly generates the DB for me, as you can see here, right? So it means it's done. Now I import Vanna, OpenAI Chroma DB, and I have my OpenAI key set up somewhere here, so I can use it from the collab just to ensure. And then here I'm doing to import my key and force it to use GPT-4o. Expectation of what's going on?
Oh, see.
Sorry, I didn't expect this one. Maybe it's not 4? GPT-4? No? What is this? Oh, I know. I haven't opened up my VPN. I need a VPN. Did I use VPN? No? Shouldn't be. 知唔知點解？
第一個 step 佢呢邊
第一個 step 係啦。
我知啊，
有咩？
呢個唔關事，佢話咩 dependency，create install 知呢，但唔關事啊，呢嚿嘢已經用咗啦。
用
應該用到啊嘛，
用到嘅。
唔知唔關呢個事。
好奇怪，之前 work 嘅咩答？突然之間 show 嘅時候，
有得㗎，
得到啦，係得到咩？
而家冇 error，你使唔使重新揾過？重新揾過啦。
冇未完㗎，未得唔知。
哦，未得嘅。
應該唔係，因為佢 DB create 咗 whatever gone wrong。好，得。OK，冇問題，多謝。閂咗冷氣就得㗎啦，係嘛？
就生咗啲嘢就
Thank you. Not expect from proxies. Why is it proxies?
我 search 下呢個，或者擺 AI，你都用唔到 AI。
可以。Why is it flexible? 有冇用？冇。
你日日都用呢個，特別係 email 呢個。
點還是 network？你 network 係 CTM 啊嘛？
係，佢後面包住咗。我知，夾包住
CTM 但係 collab 食咗 API，好似真係要 VPN 啊 ，sorry。呢個要 VPN，sorry， 我唔記得咗。好似要 VPN。I know it's a bit annoying, but yeah. I always forget when to use VPN. And choose a US. Okay, maybe just let me start over. Still no good. Maybe I'll just use another template instead.有咩冇？我知。There, here. Proxies. You mean the okay. This one.
Here you are importing this, right? And this is not compatible with what you do later. So it's problem of calling the wrong version.
Yes. Let's see here.
Because this was because you don't have
Okay, so I give up. I'm not sure what happened. Maybe some package conflict again. It's a dependency. I'm not going to use the time for this. But anyway, I can walk through the results since they are there. Okay, so I guess the step failed at some point. My package loading from ChatGPT doesn't accept my key anyway. So the next step I did is I do a Vanna connection to SQLite's MyDB. So for RAG, I does a documentation. So I'm telling OpenAI, actually behind Vanna is OpenAI I chose, the schema of my table. Okay, so NBA shots. So it's season 1, season 2, indicator for which season, which team, which player, and if the shot has been made, and what type of shot, is it 3 points or 2 points shots, and which zone, which area, etc., and XY location. And then, so to train Vanna, I import the document, and then I do a prompting here, say, please refer the following context and to understand the source. Okay, so this is the RAG training for Vanna. And then Vanna would, and then I just done. That's the RAG part for Vanna. If I try to get an answer, I just input the response, ask how many shots in total, and then it summarizes the result from the DB. Okay, and then does a count star through the whole table. Okay, and then instantly it pop up a visualized result for me. say that's the total number of shots. I can't. Sorry, at the moment I can't show you the the detail of the table since the connection couldn't be made. Actually, the connection. Oh no, sorry, no. And then inside the response, as you can see, it's a JSON format said select count star from my ask table, right? Is that correct? Yeah, it's the result I want, right? So it returns the result. Also, for visualize the result, it does a figure. It contains a video inside. Okay. So this is the actual part one. Comparing to other text to SQL, it also visualizes the results. Okay, and second try is who made the most shots? Give me the player name, and then I did ask the question, and then it gave me his is the player Luca Doncic, right? So, but the visualization part is not so meaningful. It's just the number one is him. Okay, and again the format is like this. Okay, that's the SQL query, limit by 1. Okay. The syntax, the DB syntax, since I use the Vanna one is the SQLite, so it knows SQLite syntax. Otherwise, I have to train the SQL syntax depending on the different branding, right? SQL Server, PG Server, etc. It has all different syntax. So that's pretty much set already. And third one, generate questions also. Here is the answer. Let me see. Oh, so this is the step by step to show how what's contained inside the Vanna generate SQL before it generates SQL. So you can tell the SQL it generates is correct. Also the result it generates is correct, right? So each step breakthrough, we can see the content inside the answer. And also the code for generating the graph. Of course, here behind it is the Plotly, right? Plotly generate the graph, so it uses the syntax from Plotly. So I can also always double check that by exploring the result come from it. And even I can do a figure just directly plot it out without throwing again the question, right? So it's all inside the object. It's all inside the response. Oh, okay. So that's another one. So once I generate a result, it's a Plotly PNG. So I can also store it to here. But since I don't have the result at the moment, I can't show you that. So it will show up here. And then another question is show me the shot percentage, etc. And then it gives this graph. Plot the top 3 players. Okay, so all these steps is doing the checking if the SQL it provides it answers the question I want, right? So it does the correct thing. So as I went through before, so it's pretty much it. And that's just the proof. You can run it outside Vanna, but also using Plotly, right? So yeah, a few more samples right there. Okay.
I thought LeBron James would be the top shooter.
I think no more.
No more, right? Okay.
No more. This one 2024.
All right,
the latest one.
The most updated season.
It should be correct since so many data science already checking this.
Yes.
But obviously I don't know the player myself. I haven't watched NBA for a long time. Sorry. I can only tell you can only tell by data. not
from memory.
Not from memories, no. Yeah, I hope. Sorry, I can't went through the whole demonstration since the era, but
some technical.
yeah. Any good spotting of the thing? Yeah. But I remember last time Victor already showed us some similar way, right, from the LangChain that does the text to SQL. So, but yeah, like I said, Vanna on top it add up the visualized part, so you can react with the result, and it's clearly enough. You can tell the object whether it generates the correct SQL, it generates the correct plotly code for visualization, right? And yeah, pretty much. Chroma is the one for vectorize the result, like containing the figures and the query, right? And that's the DB I made from the CSV. So those two you can see I stopped it, but they generated there, right? Okay, so if I have Dify and I have Vanna, can I boom, pen pie apple pen? I'm not sure if this can be successfully demonstrated.
So what's the advantage compared to the LangChain?
Compared to the advantage comparing with the LangChain, like you visualize the stuff, the framework itself is specialized for text to SQL. LangChain, I remember last time we have to do a proof from community something, right? For the text to SQL part. Oh, it was a zero shot?
Well, yeah, you have to use specific models. So last time I didn't use GPT-4. I used like it was like a fine-tuned version of a Llama, where it's like specialized in doing text to SQLs. So I think the advantage of LangChain would be like, it's more flexible. Like you can do different stuff with it, and one of them is to do, text to SQL. But it's like this is like it does everything for you. You don't need to set up anything.
So how about the accuracy, LangChain and Vanna?
I mean, LangChain is just a framework, so it depends on the model that you use.
Okay.
So you use like a cloud host model.
I think you can also use Vanna on top of LangChain, right? I think.
No, never tried.
I think so.
I mean, accuracy got everything to do with like the model that you use. So if you use an expensive model, then it probably does better than if you use like a.
I mean the text to SQL.
Yeah, because the bit that actually conduct the text to SQL is done by the language models.
Okay.
So if you choose, if you pay good dollars using the top-notch models, then maybe it could do better than like a self-hosting one. Yeah.
Okay, since my team views has some problem now, I guess I can't connect to my home PC. I'm really sorry. There's so many barrels today. The idea. I just brief through the idea first. So for Dify, it's possible you can do local hosting first thing first. Okay, free of course. Through Docker, it must be through Docker. Docker will orchestrate Nginx and require DB, etc. Okay, so of course aside of that, you need Ollama, right? Ollama to run with a strong, robust PC. Okay, so and then Vanna, at this moment, you cannot set it as a node. Like the question, can I do like natively setting the node? At the moment, it cannot. But the way to make a workaround is you wrap it with the API. Okay, so like you make up a fast API, and you wrap Vanna behind it. So you create create an API node, and then after. And in the workflow, of course, you integrate with that API node. So you can input your questions through API, and Vanna will generate behind, and then it will through output. Okay, sorry, I can't show this at the moment. Maybe because I changed I hate this. I changed the VPN, so it just.
No problem again.
Huh?
Stop the VPN.
I think it's maybe it's
one more time and then.
maybe it's the VPN, right? I just hate this. Did I stop already or no? Quick connect, right? Quick connect.
It hijacks your domain server, so you can't connect your home computer.
I still say Hong Kong. I haven't get used to it. Oh, okay, now. Now it's not connected. Let me check again. No, I guess no, because I use the free version, I guess.
呢個就俾錢俾錢佢睇㗎啦。Take time.
Maybe I start it again, right? So you see, that's why I love Dify Cloud. It's so out of box. You can use it right away, right? So you can tell in later if you can make everything like API enough, that you can run your own app through cloud, right? Without localize. It says online, but it's not. Anyway. Okay, I give up. Maybe. Okay, I think I leave the second part for Victor to go through. Any question about the Vanna or the concept?
I just wonder why you would use this to generate. In fact, if you have the language model, you can already ask some questions on your. So if you ask for SQL code or Kotlin code and stuff like this, it's for the developer. It's for the developer.
From the robot.
For the developer. It's for your.
For the work.
Using as a developer, right?
One of the idea was like if knowledge base would expire. So since we were talking about IG, the main purpose we're doing IG is to enhance the external knowledge. So what's the biggest external knowledge? It can be documentation, but it can also be a database, right? So database, I think that's the reason we're always curious if we could retrieve the knowledge from the database in whatever way.
But the
right?
database is going to change also.
Database will change from time to time. So that's the one way better than the static information from PDF, from text, right? So that's the one key benefit, I think, why we need to use database. Maybe Victor can add. Yeah.
Do you guys want to take a break first?
Okay. Yeah, why not? Yeah. Sure.
You guys wanna start, or you wanna keep chatting? Sure. Hi. So I got slides. So there's a slide going on. So and the topic that we're gonna talk about is still retrieval augmented generation. It's the same shit. But this time I'm gonna kind of like deep dive a little bit into like how the mechanism actually work behind the scenes. So what is retrieval augmented generation? It's really just getting relevant context for our AI overload. And really when you think about it, it's actually just a search problems. Like how do you search information that you needed so that you can fit it to the almighty LLM and then give you crap answers. So search problem really started a long time ago. When you have your textbook back in the day, how do you search for stuff? You use an index. And really early stage of like text search is also relying on that. It's just you index all your keywords or like relevant words, and then when you need to search something, you just look up at your index. And really the problem back then is not really how to index, but how do you query the index that you need. Like how do you match, if you have a spelling mistake, you won't be able to find the keywords that you're looking for. So a lot of the energy is actually spent on like how can you have better query engines. And kind of in the era of LLM, the problem is still really the same. Like there's still two key kind of like step you need to do is to index the information that you need and have a way to query those information. But because of the advance of language processing with the help of LLM, there's a lot more new tools that we have devised, and one of them is semantic search using kind of embedding space. And this is like the most simple but quite powerful steps that people use, which is a vector database. And what is a vector database? Really, you kind of have your document, you split them into a smaller chunk called chunking, and you embed each chunk, so the group of text that you have, into a vector space. And when you want to like retrieve some sort of information, you just do a similarity calculations to the embedding chunks that you have. And that's really what a vector database is. And Adam kind of showed off that in the last demo with the knowledge base, and that's really what a knowledge base is at the moment. So I'm gonna kind of showcase how to do that from scratch. So I have shared my GitHub repo on the group chat, so you guys can find the setup that I have over here. First of all, I kind of set everything up in a Docker containers. So you can, all you need to do is you pull the Docker containers, and you can like have Docker installed on your computers, and you can set this up. And there are a couple of like key services that I've built. So first of all, I have my local host language model. So it's using Mistral at the moment. I also have a second language model host. This is much smaller Llama model over here, so we can actually like compare like the effect on like using different language model. Or you can even like for certain simpler tasks, you can use a smaller language model, which is less compute intense, and for more complex tasks, you can use the bigger one. I also have a embedding model here to do the embeddings, and I also have a just the Python environment that I've set up. So really what you guys just, if you want to do the same thing, you just need to, pull everything from my GitHub repo, and then run this command here, so the docker compose up, and this is the specific compose file that I have. And the instruction is on the README, so it's relatively simple. So once you run that, I have a Jupyter notebook here, kind of just like go through like how to use the tools that I've kind of built. And so the first thing you need to do is to set this up. So I need to select my kernels, and it's running. And I also built a bunch of like helper files to do other functions. So I've built like a LLM API class, which is just like connect up to my API and then use inference. So it's really simple because all the setup is, all the local LLM inference is done with an API that is exactly the same as the OpenAI template. So you can really just, feed it. These are the data package. So you have the text that you give it to the LLM, the max token and the temperature, and then you just use response, and then you try to price it, and then it'll give you the answers. So that's what I did over here. So you're gonna have to check the LLM is running. And the first thing that I built to do this is a document handler in the class of PDF document handler. Very straightforward. And the key things that I have, kind of the first function I have built that is needed is the read PDF documents. It's very self-explanatory. What the function is trying to do is actually just trying to read a PDF. In this demo, I'm only targeting PDF at the moment, but you can expand the scope with Python. You can read pretty much all sort of document that you can find. And I also have a demo for that later on. But for now, we just assume that all our documents are just plain readable PDF. No scanned PDF, those nonsense. Just PDF that a computer can read. And first of all, you've got to open a PDF. And these are kind of just mundane steps. I'm reading the PDF document kind of by pages, and then load them into a very simple dictionary in Python. And you can see already here I'm trying to categorize the information that I need. So I have the page numbers for this specific text that is in. So later on, that's for kind of sourcing, if I find this text here, where does it comes from? A bunch of other things for analysis, such as how much word there is, how much token, and really the most important thing is the text that I've read. So here I've read the text. So I'm just using one of the PDF reader library from Python, and then all you need to do is just to get text, and you'll get the whole page of text over here. That's what this line is doing. And I am also using a sentence tokenizer from the NLPK library, which is a very old but also very speedy, useful kind of natural language processing library. And what it does is just to try to break the whole text into different, it returned me a list of string, and each string is a sentence. And you can actually just do that with very simple Python splits. Python, you can split a string using a specific characters. You can use very simple dot space, and that will give you a sentence. But there's other way to split a sentence. I'm just trying to be quick and use a pre-built library that will split the sentence for me. And that's really what this whole thing is. So I can show you what the results of that by just simply running it here. So first of all, I need to initialize my PDF handlers from the, I gotta show you the example files that I'm using. So I've got a test input, and the PDF that I'm using is the paper from Alan Turing on his kind of the most famous paper on the Turing test, and it's called the Computer Machinery and Intelligence. I think later on that he changed the title to The Imitation Game, which inspired the movie The Imitation Games. Anyway, just the paper on what Alan Turing wrote about back in 1950s on machine intelligence. So that's the file that I'm going to use. I'm going to run that and read it.
How many words in the document?
I don't know. So I guess we'll find out once I use this. So this is the read PDF file that I just showed you. It'll read the PDF. And it's done. So you can actually check the content. What is it? So I have it set up so that it return a polar data frame object, and it kind of just shows. So this is the first page. It has about 1,600 each characters, about 300 each word, and it's able to split 18 sentences out. And this is the text. And you can see like the first page, they already have kind of like a bunch of like weird stuff going on here, such as like, you know, you have titles and all that. And we won't worry about that for now. We just assume that, you know, all the text comes in a nice readable format. So once you read the PDF, and the next things that you kind of need to do, just like I showed before, you need to break them down into different chunks. And this is the chunk and embed each chunk of the text. And that's, again, very straightforward. I have a kind of, it's just really just a for loop, to be honest. You loop through each kind of like pages of text, and you section, you know, the list into the size that you want. So I have a function that also does that, which is to chunk it. And this function here, really, you can see it's just like, you know, I loop through the whole kind of the sentence, which is the group of the list of string that I have, and I break them down into a smaller chunk by using a for loop in Python. Super straightforward. And once I've chunked the sentence, I embed them. So you can see here, first of all, I chunk the sentence, and then I join them into the size that I want, and then I just throw them into the embedding things that I built beforehand. And these are the results. So let's minimize that. So this is the function that helped to chunk the whole thing. And just like before, it returns a polar database. And this is what it looks like. And really, this is kind of the essence of what a vector database is. It tells you where the chunks are. It chunks the thing, and then each chunk is now just a matrix of embeddings, just like this. So they return you kind of like a list of numbers, and that's the so-called embedding, and that's what you will use to search through the space. So really, like, once this is done, you can already have a proto-like state of what a vector database looks like over here. And I also have, you know, put in some nice statistic. If I can scroll, actually no, that's too far down. I'm not going to scroll that. But how would you query the embedding? So let's say, for example, so I have a question I'm asking regarding this specific PDF. Who's Alan Turing's? What really is going on is that I took the query that I have, who is Alan Turing, I embed that specific sentence, and I do a so-called cosine similarity. So I compare the similarity of the query to each of the embedding chunks, and by mathematically speaking, the highest similarities will be the most relevant group of text to this query that I have. Again, that's like, you know, super straightforward. I built another thing called a query handler. So really, it's just like, you know, I'll give it the PDF handlers that I have, and I'll give it the prompt or the query that I have, and I will try to find the most relevant chunk. So which is what I did over here using the vector search response. So first of all, I get the context prompt. Well, that's later on. So how would I do the search? So first of all, I need to embed the query. So I just embed it over here, and then I make a function called find similarity chunk, which is the function over here. And really, what it is doing is that I have my vector database that I just built with all the chunks that I have. I stack them in a NumPy array, and I use my prompt, and I also stack it as a NumPy array that's the same shape as the embedding stack that I have. And then I simply do a cosine similarity calculation for each kind of the query against each embedding chunks. And I return a kind of data frames that gives me all the scores of like what are the similarity like score that it has, and I filter it, very simple, for a specific threshold. And once this is returned, I actually have a prompt here, I'll show you guys later. I'll feed the top results from the search that I have with the prompt that I have given it, and this is the prompt. So I also have a bunch of prompts here. To find what is the prompt. A simple query answer prompt. Simple. There you go. So it's a very straightforward prompt. It's really just like, oh, you know, you're a helpful assistant, you're here to answer the questions. It's how would I inject it? It's really just it's a string manipulation, string formatting in Python. So I put the prompt here, put the query here, and then tell the LLM to respond the answers. So we can actually check this out. Oh, whoops. So I've definitely put the spoilers. Here you go. So let's see if I can run this, because I was getting a bit ambitious. I'm trying to have also the graph stuff on, so I don't know what I can. But yeah, it's just really simple, straightforward. I give the query handlers the vector database that I built, and then when I need to search, I just give it a prompt that I have, and it will give me the response. And then also for debugging purpose, I also have it to return what I think is the relevant chunk that I give. Let's see if I can run this. Well, I can't because I have to show you guys the next things. So that's really like, I'll show that bit later on, but that's how you really, that's what a vector database is. It's just a table of embedding chunks.
Without
like nothing.
LangChain, no use.
No, it's just you see, like all I had was just like NumPy. So you can build this using NumPy. It's super straightforward if you kind of like know the concept behind it. Like what LangChain provide and what like vector database provide is more complicated stuff, such as, you know, this is simply a cosine similarity calculations, and then, you know, I return the top results, and that's the relevant chunk. As Adam was showing before, you can have hybrid search, so you can actually mix that in with a very traditional full text search. If you index a document, you can do, there's a bunch of other techniques, but this is kind of like the essence of what like modern RAG is doing. Is really just like using embeddings, like these, all these large language models have trained their own embedding space, and then you use them to do semantic searches of sentences and informations. And
I have
yes.
a question on the chunk though. The chunk part, because when you analyze like in classic NLP, you make sentences, words, token, and stuff. It's all about basically chopping down
the strings. Yeah.
When you do your chunks here, is that you just take like your context of some kind of context of words, or you just say a fixed number of words, or how do you chunk?
So I chunk it with sentence. But as you said,
you take a sentence.
Yeah. So I have.
Okay, so you're checking.
Yeah. So I already have a sententizer here. So I use the NLP TK, which helped me break down, you know, what I think a sentence is, and return me a list of that. And I just say 10 sentences a chunk. Obviously, there's other way to, as you said, the probably most brute force way is just like fixed amounts of string characters a chunk. That will be one way of doing it.
That means you can end up, if you take a document, you say 10 sentences a chunk.
Yeah.
But that could completely overlap, like 2 paragraphs.
Yeah, so you can
end
do
up
that
with
too.
The conclusion of one
Yeah.
and start with the beginning of the other.
So
you could mix 2 concepts, right?
That's actually what I did afterward. I made an improved version of this, just like a slightly further down, where I can't really find where the chunking is. But yeah, this is the old chunking. So as you can see, it's really just I just took the list, and I just use Python to go like from I to like I plus whatever. Later on, I have it as that they overlap. In the for loop of like Python, you can set the step count. There's other way to do it. Like some people would actually give the whole things to a LLM and tell it to actually chunk it for it because they think that LLM would know better on like what a paragraph is.
Maybe you can ask your LLM to ask another LLM.
Yeah. So it really just like up to what you think is best. And obviously, if you know the data, you will know how to chunk it best. So if, for example, so I'm like here, it's just like a PDF with words.
But it's kind of universal that there are paragraphs in the text.
Yeah.
And any text has section, paragraph, that's why LaTeX can work this.
Yeah.
You have typical data preparation step.
Sessions, part,
improving the quality of your input.
That just makes sense in any language, in any kind of document. You always have this division. So
really, this is like nothing fancy. It's just about going back to the old practice of like how people used to do natural language processing beforehand. Like this is efficient, straightforward, but one of the downside, I'll talk about this a little bit now, is if you kind of like split it like this, you might have information that's relevant in this chunk and this chunk. For example, it's like if you just ask a very simple question like, who is Queen Elizabeth? And the similarity search will very easily be able to find you like, this text that is relevant to the concept Queen Elizabeth. But if you say, how long has Queen Elizabeth been the queen for? If that is not an information that is directly stated in kind of like, plain text, the similarity research might not be able to yield that result. And this is the one downside of this sort of approach, is that you assume the text that you're looking for already have the information that you needed. And that is kind of like what people were kind of like evolving in this field, is that to invent even more fancier method. And one that I find is called graph rag. Very straightforward. You build knowledge graph from the text that you have and query that knowledge graph as if it's like a database, just like a vector database. And hopefully the knowledge graph, the inherent kind of property of knowledge graph, which represent node and edges and relationship, will help you give better context in terms of answers.
I just don't want to spoil this, but I think that because before going for graph, which is kind of I would say a complex solution, you can also just combine vectors, and that could be the kind of same thing, right?
Yeah.
Just add vectors. If you have the age of the Queen Elizabeth somewhere, and Elizabeth is a queen, into things you add all these 2 vectors, and they are giving you combination.
Yeah, I didn't really go too deep into this because there's actually a lot you can do with a vector database, and that's why you kind of use a pre-existing framework instead of building out of scratch, because someone already implement all of that. I'm just really like showcasing how the fundamental of it. And there's lots of fancy ways, as you say, you can combine different factors, you can summarize them, you can have smaller chunk and bigger chunk at the same time. And then it really just now that fall back into how well do you do your algorithmic search. That's really fundamental of information retrieval. There's nothing fancy about it, really that LLM has brain, other than creating an embedding space, and that really make semantic search a lot easier rather than the old-fashioned, which is relying on keywords building and all of that. But kind of the next things that I will showcase is like a really on the other side of the spectrum is what Microsoft called graph rag. Really, as I said, like, you know, they're hoping, like, you know, with the structure of knowledge graph, like you'll be able to curate better contextual information for LLM. But then, like, how would you build a knowledge graph? Building a knowledge graph is really labor intensive, because if you go from a text document, you need to have actually a person to go like, okay, like, what is a node? A node could be a person. And what is an edge? An edge could be whatever relationship that you have. You actually need someone to read through the document, build a knowledge graph. And that's like kind of like knowledge graph is not very popular back in the day in terms of like text searchings. You know, knowledge graph is more suitable for kind of things that already exist as a graph. So, you know, user interaction, things that automatically generate from kind of like how user, like Facebook is a good example. They're the one that really pioneer using knowledge graph with kind of like how their user interact with each other and doing, you know, advertisement exploitation, I guess, with knowledge graph. But what really like Microsoft has showcased is you can actually use LLM to help you build knowledge graph. And that's really kind of the whole sketch is that instead of having a person, why don't you get an LLM to read through the document and have it to output the knowledge graph? And I'll kind of showcase how they do it here. Well, not how they do it, but how I did it reading their paper and doing a shitty implementation of it. So we back to our PDF handlers because we're still handling the goddamn PDF. And the next function that I have is this one, graph extraction. So now that I've read through parse my PDF, as they call it, so like get my program to read the PDF, I want to have my LLM to create a graph, something like this. So this is like the end result of that, and I'll go through how this is done. Oh wow, this is really laggy. There you go. So after embeddings, I actually built another function called graph extraction. Really like what it does, you can see like kind of the result is that I have my language model to read through, you know, the chunk that I have split for it, and then have it to kind of like tells me like, you know, what do you think is inside this text that you can help me to build a knowledge graph. And again, it's just actually a lot of for loops. I'm just looping through. So in here, I'm looping through my chunk that I've built before, and you know, give it relevant context. And then I go to my get graph. And what is get graph? It's really I just have a preset a bunch of prompts that I've made. I formatted them, and then I gave it to my language model, and then I invoke it and have it to return. And then once I'll show you the prompt later. But like once I prompt it out, I'll get it to parse, because I conditioned my LLM to output a JSON format. So I'll try to read the JSON format. And if it doesn't read the JSON format, I know something's wrong with that output. And I kind of just like mark it down. It's like, there's a problem here, and I'll go debug that later. Normally, like what you would do, you probably like, you know, use a, you know, agent workflow or whatever. You kind of condition it so that instead of like, you know, handling an error, you actually like tell it to like, hey, try it again or something. But because of time concerns, I just didn't do that. And I'll show you what are the prompts that I use. And it should be like all the way to the top. So this prompt files in my documents kind of just have all the prompts that I have. That's how people normally organize their prompts. Really like, again, you just really like think of like writing prompts like writing instruction for your junior engineers or whatever. You just write down what you want it to do, be clear about it, gave it steps, and tell it the results. something that I showcased last time is it would be very helpful if you give it examples. So you can read through this very quickly. Extract entities and relation from the following text and format them for a knowledge graph. Focus primarily on types. And you can actually read through the kind of like this history that I have, because I changed this prompt multiple times because initially the prompt didn't really work out, so I kind of refined it, tied that to be more specific on things.
Still work intensive then.
Yeah, well, like really, like you can't be fake with LLM. Like you gotta, the more specific you are, the better result it tend to give, because the data set that used to train LLM are very specific. Like if you go look through some of the open data set people use, like, you know, they go crazy on like telling what they do. It's kind of nuts. So the more refined and more close that you are to actually the training set, the better performance you get from your LLM. And I tell steps, so what are the steps? Like identify all the distinct entities, and then I tell like, you know, these are the things that you're looking for, so what are the entity names? This is for creating the node in my graph. The description, so I can give it more information. And then after that I say, okay, like from all these entities that you make, can you identify relationship between these entities from the text? And really, and at the end, I wanted to output a JSON format. So this is the format that I wanted to be output in. So you have entities, you give it examples like, you know, the entities will be in a list of different date, which is just in JSON, and then you're in a relationship. So the relationships is a list, and then tells like what are the source entity, target entity, the description, and the relationship strength. So these are really like, you know, kind of like if you guys build graph before, these are like just basic properties that you need in a graph. And I also gave it examples. So in here I have an example text. So
there could be also the direction of the, could be redirected.
Hey?
It could be a direction to, I mean, there's not like.
Yeah, there's no, so.
Target, but it doesn't say if it's like just a correlation or position and stuff like that.
Yeah, so in here I kind of keep it as simple as I can.
Just a side remark.
Yeah, and also I think the more complicated you get, the more likely that it could hallucinate as well. So there's a fine balance on like, you know, when you're trying to extract information from LLM, you want it to be.
Yeah, but typically if you want to have like a causality study, you want to know what is causing things, which is actually what we all want to have now.
Yeah.
Direction is, you have to have direction. You can't just correlation, nothing.
Yeah, so I guess this is kind of like I copied this format from the Microsoft approach. So they probably like, you know, did a bunch of trial and errors and find that this is like, you know, the least, like the simplest that LLM can handle, but the most information they think is appropriate.
For example, you have tool and person, or I don't know, in the entities, for the kind of entity you have tools and person, I don't know. So of course a person is using a tool, it's not the other way around, right?
Yes, yes,
like
yes. But I can actually show you, so this is a very generic approach. In the Microsoft approach, they actually ask you specify the type of entities you want to extract as the user input. So here I kind of just set it as a default because like I don't really, but like in the Microsoft paper, they actually specify that to have this to work the best, you actually need to tell the LLM what sort of relationship and what sort of entity you want to extract from the text. So the examples I gave is that they have a financial report and they just say only extract people and organizations. So really they're extracting like, you know, and then LLM will ignore kind of like other information that is in there that doesn't fit kind of like the graph structure that you want to build. So in their examples, like, you know, you need, they specify that they only care about person and organization and location. And the LLM will only kind of extract people as an entity, organization as an entity, location as an entity.
Oh, wait,
yeah.
But the interesting part, I think, is the relation there. So
yeah, and then they kind of will build a relationship based on the entity that they have. So really, like, it's about how well do you know your data, And if you don't know your data very well and kind of just let LLM run free and do whatever, I tried that before, it actually don't build a very good graph because it will see kind of everything as an entity. Like, you know, a comma can be an entity and actually write down like the number is an entity. Like, you don't want that. So there's a fine balance between like, you know, the direct, like how much you want the LLM to run free and how much you tell it what to do. And obviously the better you know your data, the better you can tell what the LLM like do. So these are kind of just the examples, and it'll be best if you can give it an example prompt. So here, like, you know, I gave it a text and say, you know, Alex is a software engineer at TechCorp, and they collaborate with Bob, who is a data scientist at DataWork, and they work on a machine learning project. And I go like, okay, now give an examples that Alex is a person, that's an entity, this is the description, TechCorp itself is an entity, so on and so forth. Actually also showcases like what are the relationship, like, you know, Alex and TechCorp, they have a relationship, like Alex worked at TechCorp and Bob also have a relationship with DataWork. And Alex and Bob has a relationship because they're colleagues working on a project. Yeah, so on and so forth. And also, like, you know, other examples such as like machine learning project, you know, that itself is a project. And really, like, these examples are key to kind of get LLM to do the right thing. So if your examples doesn't really match up with the text that you have, the LLM, there's a high chance that will hallucinate. So again, it's not like just throw it and then have the LLM to handle it. You actually need to like know sort of like what you want to build ahead of time, and then just have it to build it for you. So I have another examples here. I think 2 examples is really the key. A lot of the examples I also only give them 2 examples. This is just another example. It's just to like reinforce the like this is like what you're trying to achieve. So that is kind of like what the PDF handler job is in these things that I built. It read the PDF, it chunks them and embed them, and it try to get it to give me the JSON files I need to build a graph. So I can just run this here. Actually, I shouldn't run this because it takes like 10 minutes, I think. It takes a while to build this, like, because if you look at it beforehand, right, I have about, how many chunks do I have? I have about 82 chunks, and each chunk is about a 10 sentence. So I said it like, 10 sentence long. So you need to call the LLM 82 times to read it through. That's why like people say graph rack is expensive, because you're repeating calling LLM to do a task for you. But since I'm hosting this locally, like it doesn't cost me any money other than electricity, which is at my office, not at my home, so I don't pay for that.
Can I have a quick question?
Yes.
Will the handler turn the chunks into embeddings like numbers?
Yeah, so that's what this function is doing here. So it embed the chunks. So it was a bit of a mess before, but like if you read through the text, what it does is like it parses it breaks them down into like different, like smaller sizes, and then it passes it through the embedding models and say return me an embedding. And that's what it is over here. Like if you look at this, right, like this is the embedding object, just a bunch of numbers.
You
so on the right.
LLM, right?
Hey?
You don't do that. The next instruction, you don't use this, right? You don't use the chunks.
So here it didn't use an LLM, it just used an embedding. Whereas here it uses an LLM because it involves some sort of reasoning task, I guess.
Just to make clear that we don't use the chunks in the LLM.
No, that's very straightforward beforehand. And that's kind of like what you can expect from the LLM.
But the LLM uses its own.
They have their own embeddings. Yeah. So
it's kind of an extra layer.
Yeah. Really, like to me, it's the biggest breakthrough isn't, it can inference. It's really about like it can actually compress word data into vector space, like, and each concept actually live in a mathematical models. I think that's like the most powerful, not necessarily invention, but like tools that they have built to enhance language model. And to save time, I also have it to save as a JSON file so that I can read it later. And I don't have to go through all of that, so I can just read it. And one of the things that people talk about in terms of dealing with graph is to what they call entity resolutions. So when even humans do this, like let's say you read a bunch of like documents and then you go like, oh, you know, I found an entities here. And then like 2 pages later, you'll be like, oh, I read this thing again. You might not remember that you have actually created an entity for a thing that you read 2 pages beforehand. And therefore you duplicate your entities that you have. And this also exists in like, you know, a normal data, like humans, like let's say for example, you want to have a node that represents a person, but this person might have, you know, their name formatted a bunch of different ways. Some of them might be shorthanded, some of them might be full name. And what entity resolution really is just like, you know, you find the entity that you believe is duplicated and combine them. So instead of having 2 nodes represent the same thing, you want to combine them into 1 node. How do you do that? There is algorithm that does it, but again, I was being super lazy and I actually just got an, well, I didn't get an LLM to do it. I just do a comparison. I go like, you know, if the string in this 2 is the same, combine them into the same entity. You can actually get an LLM to do it, but that would take even longer. You can go like actually present it to like, okay, these are the 2 entities that I have. You know, tell me, do you think these 2 entities is the same entity? So that's kind of what I built in this text ingest files, and you guys can go have a look at it later. But yeah, I have various different versions. Some of them are just like, you know, do a simple string comparison. Are these 2 the same name and the same type? If so, combine them. I also have a very complicated one where I actually get an LM to like parse it for me. But really, like, you know, that's something that it's, if you start dealing with graph, that's something that you have to like keep in mind as to how to resolve your entities. You don't want to resolve them too much because then you kind of erase a lot of relationship that you might have. And some entity, they might be similar, but they might not actually be the same thing. And you don't want to accidentally like combine 2 of the things that is not the same as the same thing. So here I kind of just hand wave it. Actually, I need to read this. So I read it. So this is me like pretend that like I've run through it, read my JSON, and I now actually have 534 entities in the graph that I have built here. So this is, I'm just checking like, you know, how many entities in the graph that I built. Anyway, so, and this is the step that I talked about. You've got to resolve your entities. If you guys are interested, you can like check it out. And these are the final resolutions. So at the start, I have 534. And after resolving the entities that I have, I also saved it here, so I don't have to run through it again. So let's try reading it.
How long does it run?
I think it was 10 minutes last time I ran it to use LLM to actually resolve entity for me. Again, like you think about like how many calls you need to make. There's 500 entities, right? Like, and I'm literally just like listing it, like, you know, doing an O1 where like, or not even O1, ON, where I go like ON square actually, where I go like, okay, is this entity the same as that entity? If not, like check the next entity and so on and so forth. That's very time consuming. So, but I've done it here, so there's a less resolved graph, and I can actually see like what are the length of this. So the length of less resolved graph is about, what? I must have fucked up then. Well, that's screwed up. Oh, maybe I can just actually run through this. Here I've done it once before. It's about 340. So let's actually try to run this. So this is the fast version that I built that doesn't use LLM. And you can see that's still not particularly fast.
This LM is one you install on your machine?
Okay.
It's a local installation?
Yeah, this is a local installation. Well, I'm remoting into my computers. And while it's running, that's something that I kind of like find out while I was doing this, because as Adam showcased before, like you're always gonna have trouble with TeamViewer. It's a shit software, but it's like the only software that's good enough to use. I find that there's actually a software called Code Server, which it virtualizes a VS Code instance in your local machines, and you can actually run a cloud interface of like a VS Code, but it actually connected to your local computers. So you don't actually have to like remote into your computer and do things. You can actually like run VS Code like on your browser or something, but like in the back it's actually running like services that directly interact with your computers. So if you guys are like into like remote development or like management, definitely look into that tools. I might go try that out after this because TeamViewer sucks.
I think inside VS Code also has some remote.
Yeah, VS Code have remote functionalities, but it kind of requires you to do like networkings and all that. It's a lot easier if you just build your own instance. It's also a lot more secure as well, because I think VS Code rely on having like SSH.
Yeah, but you just cannot avoid that you need extra setup like Olama, you download codes files and set up another Docker, etc., right?
Well, that's the beauty of Docker. Once you set it up once, it's easy. Okay, so I've done this, and in this is like the easier technique that I use, where I just compare like the name and then the type of two entities, and it's gone from like 531 to only 373. That means like beforehand the LM actually duplicate a lot of entities. Maybe it read like Alan Turing names like 5 times, and it's think that Alan like that 5 entities is the different entities, but in fact they're actually the same. So once I build my graph, it goes to the next kind of like big things that is still in the indexing phase of GraphRag, which is the Graph Data Manager that I built. So let's kind of initialize that and then load that information. So what does Graph Data Manager do? Really, it's just to handle kind of like things that's very specific about graph. So there's a lot of things you can do with graph in terms of as a data structure itself. You can look for what are the key entities that have a lot of connection that goes into it. You can look for communities. So what are the group of nodes that are connected to each other? There's a lot more tightly connected. There's a lot of analysis you can do with graph. Initially, I was going to use Neo4j for that, but then I didn't really bother to learn Cypher. And I don't really understand, like really all I want to do out of this is to do community extraction. So I'll showcase what that means later on. So there's a lot of mundane kind of like admin stuff here. So it's just like really, I need to create a graph using Network X. So Network X is a Python library that handle kind of graph data structure for you. It's pretty quick, and it has a fair few other Python library that rely on Network X to do like graph analysis. So load graph from data is just like from the JSON or the dig file that I have before. I load it as an entity. So I read the entity and I add it as a node here, and then the relationship I add it as an edge here. So what is a graph? It's just a node and an edge. Also have other admin stuff such as drop existing graph. There's also where it verify a relationship have weight, so on and so forth. So once I created the load graph from data, the next things I want to do is to actually see does the graph that I created have a bunch of community? And what is a community? It's just like nodes that are highly related to each other. Once you have like, you know, relationship and entities, you can actually see like some entities are a lot more related together. So if let's say for examples, you have a history of like Game of Thrones, you know, if you've watched Game of Thrones, there are like different kind of like plot going on. You know, you have the plot that's happening in King's Landing, you have plot that happening in like, you know, north of the wall, whatever. You know, those characters, they will likely to have more connection with each other, and they themselves form their own communities. And that's kind of what we're trying to do over here, is to like help build a community, like trying to parse like structures from the graph that we have built. And I don't know how to build that algorithm, so there's a library that does that. It's called Community Louvain. It's an algorithm, it's called the Louvain algorithm, that helps find like, you know, what are the community that exists in a graph. There's different forms. This is just the one that I've used. And let's try to do that. Let's build it. And it's, as you can see, super quick. It already passed all the communities. It actually find, and this run, I find 42 communities in my graph. So that means there's 42 kind of distinct groups of nodes that are highly related to each other. And I also wrote a render method using Plotly to kind of just like showcases what exists in a graph. And you can see I also assign colors into different communities. So let's run this. And there you go. And you can actually zoom in. So you can see some of the nodes, they don't relate it to the bigger kind of groups over here. Some people said that's a problem. They said that for a useful graph, all the nodes should have relationship with each other, and the nodes that aren't related to each other, they are probably irrelevant. That's some opinions. But really, I'm just showcasing.
Which is obvious is that in every document you have specific information, the date and whatever, it has completely nothing to do with drawing, and you have the main topic, so it's not a problem. It's just you have different information in one document, otherwise why would you read something? I mean, there are things that are not
that are like probably not related but still hold key information.
Probably the author in that case is drawing, but if it was another researcher, the name of the author would be somewhere in these little nodes. And yes, it's not relevant at all to the main topic, but it's still somewhere, right?
Yeah.
So
you can actually see. So I didn't do a particularly good job at rendering this, but you can kind of see all the stuff that is relevant. You can see like the color over here is talk about chess. So this is one of the, I guess, central node for this community. And you can see like, oh, this node is talk about chess. What does chess have information? It's related to the king pieces. So you can kind of see like how a graph could be useful in terms of like understanding your documents, because it actually breaks them down into like I guess a data structures that you can kind of parse, and then it has relationship and all that kind of stuff. You see this node talk about human computers. How does it relate to the instruction tables? So it's probably something that Alan Turing talked about when he described. I don't know whether any of you guys have read the papers. I haven't, but the concept is just like, before computer exists, Alan Turing think about like, hey, what if computer can actually think? And it just goes on and on about that over here. So that's kind of like the very first step of actually building up the graph from what the LLM has provided to us. It's actually store them in a graph structure. You can do that with Neo4j. There's a bunch of other tools that you can do, but I just use NetworkX as an example. And the next things that the Microsoft paper talk about is actually having the LLM to summarize each communities. because in a way, like, you know, when it exists as a graph just like this, especially with Neo4j, it's not straightforward to parse a specific like information from the context that you have. So like each node here, you know, talk about certain things, but how would I, like, if I given a query, how would I actually search for that in this graph, right? Like it's not entirely straightforward. You can actually do a hybrid approach. You can embed all this node again. So I have description in all of this. You can actually create an embedding for the given like description, and then like, you know, use a similarity search again. That's one way to do it. But then, and that's actually one of the method that Microsoft talk about. But I guess the key thing that they have is actually the so-called community report generation. And what it does is actually, so if I can scroll to that part of the community report gen. So what I have here is that I try to get a subgraph. So just like I did, like, you know, I create a community for all the node that I have, and I'm trying to get that community itself as a graph. So that's what I did here. I use the, you know, that's one of the network X function, is to get node attributes and return me all the communities and all the node that has that communities ID, and I add them into a so-called subgraph. So that's what it's doing here. It's trying to get a subgraph of the same community ID. And in this function here, I actually pass the community node. So this is the summarized subgraph. So I get the subgraph, I actually structure them into a table. So, and I pass it into an LLM. So this is when we go back to the prompt and see what I'm trying to do here. So this is another things. Here you go. So in this prompt here, again, you kind of role playing here, you give them instruction, you're an AI assistant that aid human analysis in information discovery, The goal here is to generate a report, a text report, based on a list of entity and the relationship. And you kind of have to be a bit specific about, like, you know, what are the report structures. So again, you're trying to tell it what to do. And I also have a format, so that's important, and examples, and also the actual data that I give it to it. So this is what the format looks like. So I wanted to output a JSON again, because JSON is something that Python like to work with. And it has a title, it has a summary, so kind of just like, you know, what are the summary of that? And then the key findings. So these are the things that like Microsoft kind of talk about in their papers, that, like, you know, instead of like having a graph structure, they're trying to reduce back from the graph structure into text, and a list of text, so that this way you can actually use all the things that LLM is good at, similarity search, just simple like prompting and reading and outputting stuff. And kind of these are the structures. So this is the examples like subgraph that I've made. You know, you have, and this followed the example that I had before. So you have Alex, a software engineer, Tech Cop, an organization, Bob, data works, what are their relationship, and this is the output I wanted to see. So for this specific subgraph for this community, like, I wanted to give me a title. So the title is that this community is talking about Alex and Bob's machine learning project. And the summary is that, you know, this graph structure is talking about, you know, Alex and Bob. Very straightforward. And then give a summary, and summary is like, you know, what is Alex's role? So this is actually talking about the relation, what they think is the key relationship in the subgraph. And I have it to output of that. I also have a second example. This is actually one of the bugs that I find when I first trying to run this through. I didn't have a second example beforehand. But as you see in the previous graph, I actually have not a lot, but I have some entities that actually don't have any relationship. So they're an isolated island of their own communities, and they don't have any relationship. And when I first run this through, the LLM actually didn't know what to do with that, and they hallucinate like crazy. So because it doesn't have any relationship, it just made up relationships. So I actually have to give it an examples of like, okay, if you see something that don't have a relationship, you know, don't output like something crazy. Just give me like, yeah, this is kind of what I structured. So like you can see the examples here. It has two entities, but there's no relationships. And that like, you know, I actually gave it, you know, this is how you should talk about it. You know, there's two entities in these communities, and that they don't form any relationship. And the summary just that these are two entities. And that's kind of what this whole kind of function is doing. It's just like, you know, read the note, format them into a bunch of like strings again, feed it into the LLM by formatting the prompt. So here I store all the prompt in the dictionaries, and I just use like, you know, dot format, Python dot formats, very handy, and fit it into the thing. And also a bunch of like, you know, kind of like exception, try and error, exception handlings, all that. And once they are passed through, I praise them as a JSON because, you know, as I said, I conditioned them to report or like output all of this in a JSON format. I read them in the JSON, store them in a list, and voila, you know, I get my community over here. So I'm not gonna run this because I think last time I ran this.
Third question. Just summary of what you try to do. So I think at the very beginning we have a document, like textual document, and then we formulate this document to a graph. And then after a while we kind of convert this graph back to a document again.
Yeah.
So I'm just wondering if there is any like information loss between each of the converting processes.
Yeah. That's the whole point, is to reduce your document into key information points.
Right, I'm thinking because graph may not be a good representation for words like verbs or adjective, I guess. So I'm thinking like if this information would got lost in the middle of the process.
So that's actually something they talk about in the paper, where I kind of just like hand wave it through. So as I was saying before, like in the examples, like the example that you give and the kind of like format that you give is really important. So the first kind of prompt that I have is this one here, right? Your instruction to give it what to do. So I tell it, you know, you need to identify all the distinct entities. For each identified entity, extract the following information. The entity name, so very straightforward, what does it call? What is the type? And this type is also important because I told it beforehand, like these are kind of the things that I wanted to extract. So if it saw something that does not belong to this type, so let's say for example, and this is already a pretty wide group of like types that I wanted to extract. Person, a lot of documents talk about person, organization, location, you know, because this is a paper talk about, you know, how would you deal with like machine intelligence, or talk about like concept and processes. So what I believe is that like these type already cover all the key information I want to extract from the document. And also the last thing is the entity description. So I actually talk like, you know, have them to talk about like, you know, what are the kind of relevant information about these entities. So for example, in here, Alex is a software engineer. So software engineer is not something that I capture in this, right? Because it's not something that I tell to specifically, you know, capture as an entity. But software engineer is a relevant information to Alice. So in the note, you know, software engineer will be captured somewhere in the node descriptions. And in a way, like, you know, what this is doing is trying to reduce information into structures that you can actually save it time to process. Because like, one of the things you can actually do, you can just throw the whole document into the LLM and just like, hey, here's the order information. Now I'm gonna ask you some question. That's gonna be expensive and also kind of technically not possible at the moment because LLM has a limited window of like what it can ingest before it like forgets. So really like all of this that we're trying to do is actually just trying to reduce information into structures that you can simplify, and then you can use like math to like parse it out.
Let me clarify. I understand what you're trying to say. And is there any information in the edge, like rather than notebook?
Yeah. So in here, I also talk about. So this is the example. So you have the target node, and you have the description. What is the description? Like, what is the relationship between Alex and TechComps? Like I just say, Alex work at TechComps.
Yep, that makes sense.
And when you feed them into the community generation, that's kind of the next things that, those information is still somewhat retained when you give it to it, because I'm trying to like, pass all of those information into a list again and give it to the LLM and say, okay, summarize it further.
Yeah, makes sense. Okay.
A follow-up question: how does the confirmation process keep track of the relationship between different, I guess, chunks of information? So let's say if the document is telling a story and then we cut it into past chunks, right?
Mm-hmm.
And we convert each chunk into entities and relationship.
Mm-hmm.
But then if you want to follow the storyline,
Mm-hmm.
like the timeline of the story, but when we do the transformation like one by one,
Right.
the time kind of aspect of it will be lost, right?
So that's kind of what the entity resolution was supposed to do. So for example, as I said before, like, let's say in the first page you talk about Alan Turing did blah 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 blah, and then you create an entity about Alan Turing, and then Alan Turing didn't show up like for another 3 pages, and then by the 3rd pages they mentioned Alan Turing again, and maybe Alan Turing is also mentioned in a short form, so he's not called Alan Turing, it's just a Turing. Then the LLM when you did the first pass, or when I did the extraction, obviously the LLM is going to be like, okay, this is a new entity that I saw, I'm going to like list it as a new entity, right? And that's what entity resolution is really about, is to like, you're supposed to have 2 of the same entities in different places. You got to identify them and combine them into the same node. And when you're doing so, when you combine 2 of the node, the relationship also get combined. So when the 2 of the node get combined together, this node are supposed to relate to that. And maybe node A and node B is the same node, right? Node A related to node C, and node B related to node D. But if you combine A and B together, now this A and B node are supposed to have the same relationship with C and D at the same time, right? So that's kind of like what entity resolution is about, is to like, trying to distill like, your process of like, all this graph that you created, and you're trying to like piece them together in a way. And you're right, that could be a concern, that there's something that you identify later on and that never get resolved. That's the thing that and I guess this is kind of like the downside of like doing this. And again, the paper actually talk about it on like how to create graphs so that they make sure that they have a long, like, they have a long callback. So note that showed up like early on in the document and later on in the document, they should have a way to relate to each other.
Just a little bit of thoughts, maybe, I don't know how we can do it, but probably a direct graph could help. Like if there's an arrow between each nodes, then...
Well, there is, because in the relationship, it talk about target entity and source entity. So there is some sort of direction into it. But yeah, that's I guess it's not a perfect way to summarize your information. A perfect way to you will actually have a human to go through this. In fact, you might not have a human, you have a team of humans to do it.
This notion, the way it represented the source and target here, are just for the convenience of giving a name to 2 different nodes, but in fact there is no, here you don't have any sense of direction. You could have the hand as an apple in it, or you could have the apple in the end, whatever.
I think that work actually, like, I need to check.
Unless you give a direction, you can have source and target, doesn't mean that the source going to the target. That's what I mean.
So I think
it's just a name. You could have named it node A, node B, that's the same.
let me, so I didn't really go through this too thoroughly, but I think network X actually distinguish that.
If you specify that this is a directed graph, then it's going to go from the source to the target. But if you don't say this is a directed graph, it just doesn't consider anything. And the way you have put your information in source and target has nothing to do with the relationship. You see what I mean? You could say the toy is in the box or the box is around the toy, whatever.
Yeah.
You see what I mean?
Yeah. Obviously, you can dive further deeper and build more kind of features into this. One of the things that I guess like Microsoft really kind of just showcase is that even they're building all these structures, they're still fitting like description into kind of like each of these structures that they have. And very often it seems that they're still relying on having text information for LLM to process. So in here, like, they still put description in the edge. So each edge is still kind of like in a textual way, talk about what are the relationship of these two nodes. And that's something that like, a simple kind of like data structures will be hard to represent without like tagging like extra kind of like information on. They just kind of throw it like handwritten, it's like, here's a description. And then when because they so rely on LLM to reprocess all this information again, they kind of just assume that an LLM would be able to like extract this sort of information later on. And that's why they talk like in the community summaries, like as you said, like, it seems that we're building all these structures and then at the end we're getting LLM to like give us like goddamn reports again. And in fact, that's exactly what they're doing, is that like they are just relying on the textual processing of LLM, and all of this like kind of structures is just an extra tools for them to kind of internalize the informations. And when they do the next prompt, it's always just about providing context. Here's the instruction, context, example, user query, outputs. That's kind of what they've always been doing, and all of this are kind of just like helping them to actually do better at that.
I think it would sound weird if it's just for one document, but if you put like a few more documents together in the graph, and probably could just like...
Yeah, so I got lazy. This is only one document, but you can totally modify my PDF handlers and have it to actually store multiple documents. And in fact, the Microsoft implementation have that features. They let you add document, clear documents. There's a bunch of fancy things they can do in it.
When you say you summarize the information on it, how do you decide what is the most important information you have in the graph?
So that's something I kind of skipped, and it's in the detail. So in the Microsoft kind of implementation, they add weight into the relationship, and I mean, graph has weight and the edges have weight.
Summarizing the document.
So when they summarize it, they actually talk about that you should prioritize relationship with higher weight than lower weight. It's just straight up an instruction. I wonder, can I find it here? So the grounding rules support points with data reference like limit to 5 record ID per reference. I don't know whether I can find it anywhere. But yeah, again, like, you can see like there's like, it tells it to give it like a weight.
That's between two nodes. I'm talking about the whole document. Like, how do you summarize the whole document?
Just through this?
Because saying a car has wheels is 100%.
Yeah.
That's like super strong relationship between cars and wheels.
Yeah.
It's completely not informative about what happens in the, like if you were talking about chessboard. Yes, chessboard, there is a king. In the chess game, there is a king, right? And that's 100% certain. But that's not the most important thing about the paper in Turing, right? In Turing paper.
No.
That's my
and
point.
so
Relationships are not necessarily the only
So this comes up when they do the search. So they're still indexing so this is still indexing part of what GraphRag is doing. They simply just building up context of context in a way. So you build a graph, you build the community report. They actually have community report on top of community report. So they will feed them 5 community report and go like, okay, summarize a big summary about this summary. It's this group of summary that they have. It's just in a way, it's pretty brute force. It's really just like, how do you reduce information by giving the LLM like, hey, help me summarize this further and further.
This is really the point of the other question. In a summary, when there is a story to be told, for example, there is a notion of time. In a graph, there is no notion of time. It's just a state, right? It's just a state. There's no notion of like, I did that at this point, I did that at this point. It's like, I did different things.
So some of the examples I saw
well, you can always trick the thing, but by definition, a graph is the state.
Yeah.
So what you can summarize, for example, you cannot summarize a story. Like you can't really say, oh, this happened and this happened and this happened.
Yeah, you can.
Because this is.
I guess that's like what I meant by brute force is that like, they still leaving a lot of information in the description. So when Microsoft prompt the LLM to do this, it's like, leave description in the relationships. So, in how would you don't, as you said, right, there's no concept of time.
Yeah.
But there is information in those edges that can say, 10 years later this happens. So maybe like a node A and node B, will have a relationship saying that in the description having a time.
About a summary of a story, for example. If you want to summarize a story, you have to kind of index something with time. It's not just the past, the future, and the present. That's too simple. This would be okay, but that's not what I mean. I mean like a real-time series where you have something that is actually moving with time. And you are not going to index this by 10 years ago, 9 years ago, 8 years ago. It's not like this, right? You say, I did
You said it's not like that. That is the exact example that I gave in the Microsoft. They literally they show 3 cases. They show a financial report. They use Game of Thrones as one of their example texts. And they were just like, what the LLM does is literally just building text information into the edges. And then, they are relying on the LLM understanding of the text information to provide a summary. So when you say, how would they summarize the stories, right? It's literally just like, if the graph are able to piece together the community, and hopefully the relationship will have kind of this information, they will show up in the summary.
Okay, so you mean that there is some kind of index of time appearing in the nodes that
and the edges, as textual information. So as you say, there is no specific structures about time or other concept. They are brute forcing it by inputting that in the description.
So the graph kind of embeds some kind of index of time.
It's not elegant. I would say it's not elegant. They really they're really just relying on textual processing of the LLM to hopefully they can retain those information. And I guess that's why there's so many approach of this, because as you said, there will be more specific use cases that rely on, this is very computationally heavy. The fact that you need the LLM to read this, summarize that, read this, summarize that, that's costly, right? And if your data set is more catered to a specific structures, that's what you should build for your data set. And then have that pass it on the LLM. The LLM couldn't do that just yet, unless you specifically give it instruction to, or you design the data formats for the context building for the LLM. So this is still not, I wouldn't say this fit with everything, but they really do brute force it through. Anyway, so that's building the communities. But how would you search once I have all this community? Let's say I do have a question how would I actually search all of that? So so I'm not gonna run this because it takes about 10 minutes to run. I'm just gonna use the load community reports because I'm lazy. Finally, it comes to the query engines that I have query handler, not engines, that I've built. So beforehand, we did the factor, we haven't done the factor search, so let's try that. So this is using the chunk stuff, the embedding stuff that I built it for. So I asked, what is a digital computers? And then let's see what is the response. The response is that the digital computer is a blah, 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 blah. And then let's actually see what are the chunk that it uses for context. So you can see it actually find kind of like 3 chunks, and this is a similarity score that it has. I actually filtered out, so it only returned me similarity score that is higher than 0.5. And these are the 3 kind of chunks that it think is relevant using that method. And then they give it into the context and they generate that output. And here is what they so-called global search. So there's 3 kind of big search methods that Microsoft have built for this graph rack approach. One is called global search, one is called local search, and the other is called drift search. And I've only managed to implement global search because this is a slightly easier implementation. But really, it's just like, as I said before, once you index all the information, how would you search it? And this is what they believe is the way to actually, you know what, I'll just show you the data flow first. So this is what Microsoft call whole data set reasoning. You have a user query, and if you can fit in also the conversation history. And what it does is that it actually, for each kind of community reports or community summary that you have, you pair the LLM and the user query and have it to generate a intermediate response. So it's, again, super brute force. You just look through each of the community summary that you just created, have the LLM to go like, okay, for this query and this community summary, give me an intermediate response that is relevant. And if it is not relevant, don't output anything. And once you go through all of that, you rank it and you do a filtering because, again, like, they put in like, a score in the information that it has, aggregate it, and then give it back to the LLM, go like, here's the aggregated community report, here's the aggregated summary that I provided. Can you answer the questions based on all of this information? And as you can see, like, if you have a lot of community report, even during inferencing, there is a lot of like LLM core in it. So let's see what I did here. So first of all, here's the intermediate. So really, I just loop through the community summaries, give it to the LLM against the user query and go like, here is the, give me an intermediate response. And actually, I showed you the prompt on what it is doing. So this is the community report, reduce global search prompt. There you go. So actually no, this is the first one. There you go. You have the map response. There you go. So generate a response consists of a list of key points that respond to the user question, So really, what you're doing is that you give it, as I said, give it a community summary, give it a user query, and go like, based on this community reports / summary and the user query, can you give it any key information that will respond to the user questions? And if it doesn't, don't respond anything. You just keep looping through that, and then you'll have a list of intermediate response. And then the next steps that you do is to reduce it. And again, this is even more straightforward. Generate a response based on the summarized report. So, you know, I have the analyzed report, so all the summary that I extract out, give it here. Oh, Jesus, it's running out of batteries. And then it can output a user summaries. So let's see that in action. So this is the and you can see it's pretty slow, so it find that, oh, community 0 actually gave an appropriate response, so I have it printed out. And the question is, tell me what Alan Turing think about artificial intelligence and how to measure it. So this is the question that I have. Yeah, I wonder would it run before my computer died. But here's the kind of like preamp examples answers that I have. So Alan Turing is a renowned computer scientist proposed a Turing test to measure a machine ability to exhibit intelligent behaviors. So the answer is actually not interesting. The most interesting piece is actually what are the intermediate response that it gave. Because I kind of give you the idea of like what the LLM is doing. So if I go, I have to wait for it to finish doing this thing. Intermediate context. And to answer this question, it took 1 minute and 20 seconds on my local 2080 Ti. And kind of here is the description that it gave based on what it thinks the community summary actually tells it. And it has a bunch of scores over here. And these are the summary that it read from the community summary that it just gave. So Alan Turing proposed the Turing test that was relevant to our question. This is more or less the same thing again. They talk about the Turing test. Again, he's like talk about Alan Turing again about the imitation game. So imitation game is kind of like another thing that they talk about in the paper. What Alan Turing believed, the argument for consciousness. And you can see like it ranked from top to bottom. So like the first one is like super relevant to our questions. And the LLM gave it a score of 100. And then the last one is like, you know, it talk about writing machines' potential to perform things. And it's not really relevant to our question, but it's relevant enough that, you know, it read the community summary and decided to give a response and get it like a score of 60s. So this is just like a super brute force way, just relying on LLM call again, and again.
I missed that part. So the final answer is actually they give you the 100, the one with the 100.
So the final answer is actually the first one here. So there is a part where it gave it all of this, gave it to the LLM again, and go like, based on, you know, this summary that you just gave me, and the user query, now give it a final response. So you can kind of count like how many LLM call we just made. Like to simply answer these questions, not even counting about indexing the whole thing, right? Like 1, 2, 3, 4, 5, 6, 7, 8, the final response. Simply answering this question, it took 8 LLM call to answer this question. But based on the Microsoft research, it said this actually give a really good, like from whatever test that the benchmark that they use, it outperforms simply, you know, RAG or not using RAG, you know, because it actually piece through information to answer the question by, you know, pre-building all of this structure that I just showed you. They also have like a cost analysis. So apparently, like they were using their financial reports to run kind of like, you know, a question to index their financial reports. It cost them about $50 US, and it was like a 10 pages PDF document, and it cost them $50 to index it. when they first announced this, like about a year ago, using GPT-4, which was super expensive back then. It's definitely got a lot cheaper, but again, it shows you like, this is like an expensive approach, but like kind of foresee like, I guess what they're gonna do in the future is, a lot of times it's gonna be LLM calling LLM calling LLM. Anyway, I guess that's the end of the presentation. I just kind of showed you, run through all the code that I have, and my computer just died. Any question other than
the paper in your PPT?
It's just called GraphRag. So if you search Microsoft GraphRag, and they're still coming up with new approach. So like a couple of weeks ago, they had a new search approach, which is a lot cheaper and don't rely on LLM call. They were kind of like going back to the basic, using traditional kind of like indexings and like graph searching or whatever. Haven't read that yet, but they said that it's a lot faster with kind of like some penalty to so-called like performance, which is like how accurate they believe the results are.
So how long did it take you to implement this?
Well, I have work. I have a full-time job. It took me like maybe 2 months. The first bit, like the first bit about the embedding chunk, that's like super easy. I kind of just like read through it and then go like, oh, it's really just about building a bunch of like tables. That's what it is about. And doing the GraphRag is slightly more complicated because you kind of have to understand like, it's not complicated in terms of like the concept, but it's complicated in terms of like if you actually need to implement it. It's really just about like how can you get the LLM to read and then to reduce to a summary, and then how do you like build kind of like a structures for those summaries, so when you need to query it, you can call them out like super quickly or whatever, or how do you like and as I showed you, you can just brute force it. You don't actually need to call anything. You can just have the LLM to go like, read that summary. Is that relevant? If so, like, give me a intermediate response, and then go on to the next one. Is that relevant? No, don't give me a response like that. Yeah. Cool. Well, I guess I can't show you any more stuff. My computer died. So.
Okay.